Hello students. Now today we will going to discuss theory of computation. First we'll start with the introduction of theory of computation. Let us discuss the definition. Theory of computation is a branch of computer science that deals with how efficiently a problem can be solved on a model of computation using an algorithm. That means to solve a problem we can use a model, and on that model how efficiently the problem can be solved using an algorithm, that is there inside the theory of computation. Theory of computation, or inside this subject we have number of models which can be used to solve a problem. Theory of computation can be divided into three branches: automata theory, computability theory, and complexity theory. Now first we'll discuss automata theory. Automata theory is a theory that deals with the definition and properties of various mathematical models of computation. Now model in the sense we can say finite automata, context-free grammar, or Turing machine. These are some examples of models which we will going to discuss in the same subject. Now we said that automata theory is a theory which will going to deal with the definition and properties of the models provided by theory of computation. Now the next theory is computability theory. Now this theory will going to deal with what can be solved with the model and what cannot be solved. What can be and what cannot be solved with that model, that is there inside computability theory. Now the last theory is complexity theory. Now this type of theory, or this theory, will going to group the problems based on their complexity, whether that problem is complex or whether that problem is easy. Based on that it will going to group those problems based on their hardness. We can say whether that problem is very hard, whether that problem is somewhat medium hard, whether that problem is very easy. Based on that it will going to group those problems. So this is there inside complexity theory. Now next we're going to discuss the basics required for theory of computation. Now these are the basics required for a particular language. Now the first one is the symbol. Symbol is nothing but a character. Any symbol we can say, or any character we can say, it is a symbol. Now don't get confused with the alphabets, new alphabets which we have in English language. Now here we're going to consider it as a symbol. Now check here the example. A, B, C up to Z, we can say that these are alphabetical characters, or you can say symbols. You cannot say alphabets here because these are what symbol, because later on we're going to discuss what is alphabet. Now next one is 0, 1 up to 9. We can say that these are numeric characters or numerical symbols. We can have special characters also like plus, minus, star, dollar. We can say these are special character symbols. Now next we have alphabets. Now what is this alphabet? Alphabet is a set of characters which is actually alphabet. It is a finite set of symbols and is denoted by sigma. This is nothing but a set, we can say, denoted by letter sigma. Now set of characters, or you can say set of symbols, which we discussed here. So the set of these things we can say it is a sigma. Now check the examples. Sigma 0, 1. Now this is the set of binary alphabets. Sigma A, B, C up to Z, we can say all lowercase alphabets. Then we can say sigma A to Z, small a to Z, capital A to Z, 0 to 9. We can say that this is a set of alphanumeric alphabets. So these are what? Alphabets, which can be represented with the help of sigma. Now next is string or word. Now string or word is a finite sequence of symbols chosen from sigma. Now whatever set we are having for sigma, based on that set, whatever combination or sequence of these symbols we're going to get, that is nothing but a string or word. It can be represented with the help of symbol W. For example, we can say 0, 1, 1, 0, 0. This is one string which can be extracted from sigma is equal to 0, 1 from binary alphabets, you can say. Now symbols are the basics, that are the characters. Then we can have alphabets over these symbols. Alphabet is actually the set of the symbols, and from these alphabets we can have strings or words. So these are the basics which are required for this language. Now next is a empty string. Now if suppose there is no symbol in a string, we can say that that string is empty string. That is, the empty string is the string with zero occurrence of symbol, and it is denoted by the symbol epsilon. Now next is length of a string. Now how to calculate the length of string? The number of symbols in a string is called its length, denoted by mod w. So with the modulus like this mod, we have to represent the length of the string. For example, suppose the length string is 0 1, we can say the length of this string is 2, which can be represented as mod w. So this is the length of a string, you can see. Now suppose we have a string 0 0 1 1 1 0 0. Now if we have to calculate the length of this string, we can say 1 2 3 4 5 6 7. So 7 characters in it. So this is the length of a string. Now next we are going to discuss power of an alphabet. We write it like this: sigma raised to k for some integer k to denote the set of length k with symbols from sigma. In other words, we can say sigma raised to k equal to w, that is nothing but a string, such that w is a string over sigma and length of w is k. Now we can say that sigma raised to k is a set of length k. That means sigma raised to k, which is the set which will going to include a number of strings, and the length of each string is equal to k. Clear? Now sigma raised to 0 means what? Denotes the set of all strings of length 0. That is, sigma raised to 0, we can say it is giving epsilon over binary alphabet, suppose 0 1. Now suppose we have to calculate for this binary alphabet 0 1 powers of an alphabet, that is sigma raised to 0, we say that it is epsilon. Sigma raised to 1, we can say the length of all strings over this alphabet of length equal to 1. Now which strings we can extract with 0 1 of length 1? That is, we can say the same 0 and 1. Now sigma raised to 2, we can say that sigma raised to 2 is a set of all strings of length 2. So over this alphabet, how many strings we can extract of length 2? So to calculate this thing, what we're going to do is take this number of symbols which are there in that alphabet, that is equal to 2, and take the power of it. Like 2 raised to 0, we can say only 1, that is 2 raised to 0, we can say only one letter or only one symbol will be there in this set. Now 2 raised to 1, we can say equal to 2. 2 raised to this one, we can say equal to 2. Only 2 elements will be there in that particular set. For this next one, we can say 2 raised to 2, that is equal to 4. So we can say that for this set we can have 4 elements or 4 values, like 0 0 0 appended to 0, then 0 with 1, so 0 0 and 0 1. Next take this one input 1 with respect to 0 1, that is 1 0 and 1 1, 1 0 and 1 1, like this. Now for next one we can say 2 raised to 3, that is equal to 8. So we can have total 8 values in this set. So this is your input symbol set, and this is 2 sigma raised to 2, you can say. Now what we have to do is 0 joined with each of this. That means if we have symbol 0, we can get 1 2 3 4, total 4 values. If we have next input 1, we have to join this next input to all of these 4, so we can get next 4, so we can get total 8 values over here. So 0 joined with all of these, that is 0 0 0 0 0 1 0 1 0 0 1 1. So we can say that this is for 0. Now next input is 1 1 appended to all of these, we can say 1 0 0 1 0 1 1 1 0, and last one is 1 1 1. Clear? Now next is cleanse closure, that is represented with the help of sigma star. Now this is actually the union of all powers of sigma, that is, you can say sigma raised to 0 union sigma raised to 1 union sigma raised to 2 union sigma raised to 3, like this. That means, suppose for the same example, if we suppose to calculate sigma star, we have to make the union of all of these sets. So we can say that for this example, sigma star will be first epsilon, then 0 1, then whatever next terms 0 0 0 1 1 0 1 1, then whatever the next, that is 0 0 0, like this will have sigma star. Now this union is called as sigma star, or you can say Klein's closure. Now next we have sigma plus, which is called as Klein's plus. Now this is sigma plus is actually excluding epsilon. Now here we were having sigma raised to 0 and then the union of all of the powers of sigma, but here we have to exclude sigma raised to 0, that is epsilon. We're not going to consider it. Just remember, this star means we have to include everything from starting from 0, and plus we have to start with 1. Now next we're going to discuss languages. A language over an alphabet is a set of strings over that alphabet. Therefore, language L is any subset of sigma star, we can say. That means what? In a language we can have, or language is a set of strings, we can say, in which we can have strings of any length. So we can say this is one language. Getting this? So language is nothing but set of strings over an alphabet. Alphabet is nothing but the symbol, that is input characters.